This PowerPoint presentation is going to be a quick math quiz, multiple choice. I will answer the questions by working through them step by step. It's got contact time, dosage, specific gravity. As always, a preface: I claim no ownership to any of the questions or material presented in this video, as everything I found is sourced off the open internet. I, to the best of my knowledge, have answered the questions correctly and given the proper formulas. This is a study guide for me to help me learn. If it helps you too, that's great. Question number 1. If a free chlorine residual of 2.5 milligrams per liter is measured at the end of a clear well after 4 hours of detention time, what is the CT value in milligrams per minute per liter? 10, 200, 400, or 600? So we pull our known and our unknowns out. So what we know is the 2.5 milligrams per liter. It's 4 hours of detention time. What we're looking for is the CT value. The formula for CT value is disinfectant residual concentration, milligrams per liter, times the time. Notice the time units must be compatible, and we are looking for minutes. So the time that was given to us was in hours, and again we're looking for minutes, so we're going to have to do a conversion. There are 60 minutes in an hour, so 4 hours times 60 minutes gives you 240 minutes total, times the 2.5 milligrams per liter. That's going to give you an answer of 600 milligrams per minute per liter for your CT value. Question number 8. In 24 hours, 4.2 gallons of 12% hypochlorite solution is fed. How much, in gallons, would you have to use if the concentration was 7%? 2.4 gallons, 5 gallons, 7.2 gallons, or 10.1 gallons? So first we're going to pull out our known and our unknowns. So we have 4.2 gallons of 12% solution. What we don't know is how many gallons of 7% solution we need. So first thing we need to do is find out the pounds of pure chlorine required. So we're going to rearrange this formula. So pure chlorine required pounds per day is equal to the sodium hypochlorite gallons times its purity as a decimal times 8.34 pounds per gallon. So you plug in your 4.2 gallons times 0.12 times 8.34 pounds a gallon, and that gives you pure chlorine required pounds per day is 4.20 pounds. Now that we know the pounds, we can solve for the percent solution. So sodium hypochlorite gallons of pure chlorine required divided by the percent purity as a decimal times 8.34 pounds a gallon. Plug your numbers in: 4.20 pounds a day divided by 0.07 times 8.34. That gives you an answer of 7.2 gallons. Question number 9. A treatment plant uses 12.5% hypochlorite to disinfect the water. The required hypochlorite dosage is 2 milligrams per liter, and the plant flow is 300,000 gallons per day. How many gallons of 12.5% hypochlorite are required? Note, 12.5% hypo has 1.25 pounds per gallon available chlorine. Is it 5.1 gallons, 4 gallons, 12 gallons, or 400 gallons? First, let's find our known and our unknowns. We have a flow of 300,000 gallons per day, a dose of 2 milligrams per liter. Purity is 12.5%, and the available chlorine is 1.25 pounds per gallon. We are looking for gallons. So to solve this, the equation of feed rate gallons per day is equal to the flow, million gallons a day, times the dosage, milligrams per liter, times 8.34 pounds a gallon, divided by the active ingredient weight. First, we need to convert our 300 300,000 gallons per day to million gallons a day. So we're going to divide that 300,000 by a million. Gives you 0.3 mgd. So now we can plug our stuff into our formula. 0.3 mgd times 2 milligrams per liter times 8.34 pounds per gallon. We're going to divide that by 1.25 pounds per gallon. And that gives you an answer of 4.0032. And of course, that will round to 4 gallons. Question number 10. At a flow rate of 375 gallons per minute, how many pounds of 67% calcium hypochlorite would be required to maintain a 0.8 milligram per liter chlorine residual in the finished water if the chlorine demand is 0.8 milligrams per liter? 3.6 pounds, 5.4 pounds, 7.2 pounds, or 10.8 pounds? First, pull out your known and your unknowns. So what we know is 375 gallons per minute, a purity of 67%. The residual desired is 0.8 milligrams per liter, and the demand is 0.8 milligrams per liter. What we don't know is our dose, or our pounds, for our formulas. First, we'll find the chlorine dose, which is equal to the demand plus the residual. 0.8 milligrams per liter plus 0.8 milligrams per liter is going to give us a dose. That dose is 1.6 milligrams per liter. Now we're going to solve our feed rate, pounds per day, which is the dosage times the flow, million gallons a day, times 8.34 pounds a gallon. First, we need to get million gallons a day. So if you times the 375 gallons per minute times 1,440 minutes in a day, you divide that by a million. That gives us our flow mgd is 0.54. Plug all that stuff into our formula. 1.6 milligrams per liter times 0.54 million gallons a day times 8.34 pounds a gallon. And the answer is 7.20. That's one of our choices, but we have not finished yet because the percent purity was 67%. So remember, to find the purity, we're going to divide it. So calcium hypochlorite pounds, pure chlorine required pounds a day, divided by the purity as a decimal. 7.20 pounds per day divided by the 0.67. That's going to give you an answer of 10.74 pounds, which will round up to our answer D, 10.8. So you got to be careful with some of these questions they give you, because they'll throw in parts of the steps as answers, because if you'd have stopped, you're like, oh, I have the answer, but you really didn't, because we still had another step. So just take that into mind when you read your questions. Question number 11. How many pounds of dry chemical must be added to a 50-gallon day tank to produce a 0.5% solution? 2.1 pounds, 4.3 pounds, 6.2 pounds, or 8.3 pounds? So we're going to pull out our known and our unknown. We have 50 gallons, and we want to make a 0.5% solution. What we're looking for is pounds. Pounds of chemical is equal to the amount of solution needed in gallons times the solution strength as a decimal times 8.34 pounds. So 50 gallons times 0.005 times 8.34. Just remember, it's the percentage as a decimal, so we have to take that even farther out. And the answer is 2.085 pounds, which will round to 2.1 pounds. Question 12. How many pounds of caustic soda are there in a gallon of caustic soda that is 25% pure that has a specific gravity of 1.28? 1.33 pounds, 2.66 pounds, 3.99 pounds, or 4.99 pounds? So get our known and our unknowns. So it's 25% purity. The specific gravity is 1.28, and we're looking for the pounds. So the formula to solve for this is 8.34 pounds of water times specific gravity times the purity is a decimal. So 8.34 pounds times 1.28 times 0.25. That's going to give you an answer of 2.66 pounds. So the answer B, 2.66 pounds. Question 13. How much does a 55-gallon drum of zinc orthophosphate weigh if the MSDS says the specific gravity of zinc orthophosphate is 1.46? 11.5 pounds, 111.8 pounds, 312 pounds, or 670 pounds? So we're going to pull out our known and our unknown. So what we know is that 55 gallons, specific gravity of 1.46. What we don't know is the pounds. Formula to solve is 8.34 pounds, which is water, times the specific gravity, times the gallons. 8.34 times 1.46 times 55 gallons. That's going to give you an answer of 669.7, or if you round, 670 pounds. All right, that was just another little quiz, a couple questions. Like I said, doing this helps me. It's helped me learn. Helps you too. That's great.